Before we begin, take a moment to breathe. And if you are a member of this channel, thank you. Your presence here, your patience for wonder, allows these journeys to exist. This space is built slowly together. You are taught early that sound needs air, vibration, something to carry it. Yet the universe is mostly silence. No wind between the stars, no echoes in the dark, and still something happens. On a quiet day in December 2004, instruments across Earth suddenly react. Satellites flinch, sensors saturate. For a fraction of a second, space floods them with energy so intense it feels almost physical. As if the universe has shouted without making a sound. You are not hearing noise. You are witnessing force. The phrase, "the loudest sound the universe ever made," is misleading but irresistible. Because what truly arrives is not sound waves, but power. A surge of gamma radiation so strong that it briefly alters the upper atmosphere of Earth, despite coming from halfway across our galaxy. Imagine standing in absolute silence and feeling a pressure pass through you. Not heard, but sensed. That is how this story begins. Far beyond familiar stars, buried deep in the Milky Way, exists something small and impossibly dense. A remnant, collapsed core, a star that has already died, yet refuses to rest. It is called SGR 1806-20. At first, it seems unremarkable, just another distant object catalogued by astronomers. But this star does not shine like others. It waits, it stores, it tightens itself under forces that bend matter beyond intuition. You are used to thinking of stars as gentle furnaces, burning steadily across billions of years. But some stars end differently. Some collapse into neutron stars, objects so dense that a single teaspoon of their material would outweigh mountains. And a rare few become something stranger still, a magnetar. This is where the universe begins to stretch language. Because magnetars possess magnetic fields so strong they distort atoms, crack solid crusts, and rewrite the behavior of matter itself. Fields trillions of times stronger than Earth's. If you could stand near one, you cannot. The magnetic force alone would tear the electrons from your body. SGR 1806-20 is one of these objects. Quiet, distant, and tightly wound. For years, it releases small bursts of energy, whispers compared to what it is capable of. Astronomers observe patiently, unaware of what is building beneath its surface. Inside the magnetar, pressure rises. The crust, rigid and crystalline, resists until it no longer can. And when it breaks, it does not crack politely. It ruptures. In that instant, the magnetic field rearranges itself violently. Energy trapped for centuries escapes in less than a second. Gamma rays surge outward, not as sound, not as light you can see, but as pure, penetrating force. This is not an explosion you hear. It is an event you feel even across space. Earth feels it. Our atmosphere ripples. Our instruments are overwhelmed. For a moment, the universe reminds you that silence does not mean safety. And as the data settles, one question remains, hanging gently in the quiet that follows. If this was not sound, what exactly just touched us from across the stars? And as you sit with that question, the story begins to turn inward, toward the impossible object that made the universe seem briefly alive. You imagine collapse as an ending. A star runs out of fuel, gravity wins, and the story is finished. But for neutron stars, collapse is not an ending, it is a transformation. SGR 1806-20 begins as a massive star, burning fast and bright. When its fuel is exhausted, gravity takes over completely. The core falls inward so violently that protons and electrons merge, forming neutrons. What remains is incredibly small, barely the size of a city, yet heavier than the sun. You are now dealing with matter pressed to its limit. In this state, the star spins rapidly. Its gravity is so strong that space itself curves sharply around it. Time slows near its surface, but a magnetar adds another layer. During collapse, the star's magnetic field is compressed, amplified, and twisted beyond reason. Lines of magnetic force wrap tightly around the object, storing immense energy like a coiled spring. This magnetic field does not sit quietly. It stresses the star's crust. Imagine a shell of solid iron, kilometers thick, wrapped around a core of superfluid neutrons. The crust wants to remain rigid. The magnetic field wants to move. For years, sometimes centuries, the crust resists. Inside SGR 1806-20, the pressure grows invisibly. No light changes. No warning is sent. Until suddenly, the crust fractures. This is called a starquake. But the word is gentle compared to the reality. When the crust breaks, magnetic field lines snap and reconnect at nearly the speed of light. Energy erupts outward in a focused, violent release. On December 27, 2004, that release is extraordinary. For 0.2 seconds, SGR 1806-20 becomes the brightest source of gamma rays ever recorded from outside the solar system. Brighter than anything else in the galaxy except the Sun, despite being 50,000 light-years away. You pause here, because this means something profound. Energy released long before humans existed, before Earth had cities, before language, has just arrived. It travels silently for tens of thousands of years, crosses spiral arms and dust clouds, and finally touches our atmosphere. Instruments detect it as saturation. The signal is almost too strong to measure. And yet, Earth survives it easily, a reminder of both the scale of the universe and our fragile distance from danger. Astronomers reconstruct the event carefully. They realize that if this magnetar were only a few thousand light-years closer, the effects would be far more severe. Not extinction, but disruption. Technology would feel it. Satellites would suffer. The sky itself might briefly glow. This knowledge settles quietly. SGR 1806-20 is not malicious. It does not act with intent. It simply obeys physics taken to extremes. And in doing so, it teaches you something unsettling. The universe does not need violence to be dangerous. Only density, only pressure, only time. As the gamma-ray flare fades, the magnetar continues spinning, wounded but intact. This magnetic field slowly rearranges. The surface cools. Silence returns. But now you understand that silence is not peace. It is stored energy. And somewhere inside that quiet, another question forms. If this was the strongest flare we have seen, what else is the universe holding back? The magnetar grows quiet again, and your attention drifts outward, toward what such power means for everything that exists beneath the stars. You often think of space as empty, a vast separation between meaningful things. But space is a messenger. When SGR 1806-20 releases its giant flare, the energy does not rush. It moves at light speed, steady, unhurried, unstoppable. For 50,000 years, those gamma rays travel. They pass stars that are not yet born. They cross regions where planets will one day form. They ignore gravity wells, dust clouds, and darkness. Nothing stops them. By the time they arrive, Earth is a world of signals. Satellites orbit quietly. Instruments listen constantly. We are ready without knowing it. The flare strikes the upper atmosphere first. Gamma rays collide with atoms, knocking electrons free. The ionosphere briefly changes its behavior, measurable even from the ground. This is remarkable, because it means something unimaginably distant has reached down and brushed the skin of a planet. Scientists analyze the data slowly. They compare instruments across continents. They realize what they have witnessed is unprecedented. Not a supernova, not a black hole merger, but a magnetar flexing its magnetic field. And they begin to ask new questions. Could similar flares explain mysterious gamma-ray bursts seen in other galaxies? How often do magnetars do this? What are the limits of matter under such conditions? SGR 1806-20 becomes more than a curiosity. It becomes a laboratory, one that cannot be visited, but can be listened to. You realize something subtle here. The universe does not announce itself with clarity. It offers fragments, signals, moments. And understanding comes not from volume, but from patience. The phrase loudest sound lingers because humans need metaphor. We borrow familiar language to describe unfamiliar power. But this event is not about noise. It is about scale. Scale of energy. Scale of time. Scale of consequence. If a star can reshape Earth's atmosphere from across the galaxy, what else is quietly influencing us? Cosmic rays pass through your body every second. Neutrinos stream through Earth without stopping. Gravity waves ripple space-time, unnoticed. You live inside a universe that is constantly touching you. Most of it you never feel. SGR 1806-20 simply made that contact obvious. As years pass, the magnetar dims. Astronomers continue to watch. They know another flare will come, someday, though perhaps not in their lifetime. And that knowledge softens something. The universe is not hostile. It is indifferent, yet it is also deeply connected. You are not separate from these events. You are downstream of them. Every atom in your body was shaped by ancient stars. Every signal you receive is part of a story still unfolding. And as the data fades into archives, one final reflection remains. Understanding the universe is not about predicting its next shout, but learning how to listen to its quietest truths. Last lines, and in that listening, your thoughts begin to turn inward, toward what it means to exist in a universe capable of such power. You are still here. Earth spins calmly. The sky looks unchanged. And yet, you now know something you did not before. The universe is capable of releasing unimaginable energy, silently. SGR 1806-20 does not threaten your daily life. It does not loom above you, but it reshapes how you understand reality. Because it proves that extremes are not rare exceptions. They are natural outcomes of physics taken far enough. Magnetars exist because gravity, density, and magnetism have no preference for comfort. They follow rules, not intentions. And within those rules, astonishing things occur. You may wonder if such events could harm us. Science answers carefully. Yes, closer magnetars could affect technology. Yes, cosmic events can influence planetary environments. But fear is not the lesson here. Perspective is. The universe has been violent, brilliant, and transformative for billions of years. And yet it has also produced calm, oceans, thought, and curiosity. Produced you. You are the part of the universe capable of reflecting on itself, of measuring distant explosions and turning them into understanding. SGR 1806-20 does not shout at you. It invites humility. It reminds you that silence is not emptiness, that calm skies hide ancient forces, that knowledge arrives slowly, carried by light that has been traveling longer than civilizations have existed. And still, you listen. You sit with the idea that something 50,000 light-years away briefly touched your world. Not to harm it, but to be known. This is the quiet miracle of science. Not control, not dominance, but relationship. As the universe continues its long unfolding, there will be more flares, more collapses, more silent messages crossing space. You will not hear them, but some part of you will understand they are there. And in that understanding, the universe grows a little less distant. Last lines, because the loudest moments are not always the ones that echo, but the ones that leave you quietly changed. After everything you have learned, something subtle begins to shift inside you. The story of SGR 1806-20 no longer feels like a distant headline or an isolated event. It feels like a doorway. Science often promises clarity, but what it truly offers is a refined sense of uncertainty. The more precisely you measure the universe, the more carefully it resists complete explanation. You now understand magnetars well enough to describe them, model them, and predict some of their behavior. You know how their magnetic fields twist. You know how their crusts fracture. You know why energy escapes as gamma rays instead of sound or light. And yet, when you look closely, the edges blur. What exactly happens inside matter at densities beyond atomic structure? How do magnetic fields behave when they exceed every laboratory limit ever created? What laws remain unbroken, and which quietly give way? SGR 1806-20 sits at this boundary. It is not just an object in space, it is a stress test for reality itself. Every giant flare becomes a natural experiment, asking questions no machine on Earth could ask safely. Each burst carries information about forces that existed long before planets cooled or life began to wonder. But that information arrives fragmented, incomplete, filtered through distance and time. You never receive the full message. And perhaps that is the point. Human understanding does not advance in leaps of certainty. It advances in small adjustments, moments when old models fail gracefully and new ones begin to form. The 2004 flare forced scientists to rethink the upper limits of neutron star behavior. It challenged assumptions about gamma-ray bursts in distant galaxies. It blurred the distinction between rare and possible. Some short gamma-ray bursts observed far away may not be cataclysmic explosions at all, but magnetars briefly tearing themselves apart and surviving. This realization changes how you read the sky. Events once thought singular now feel connected. Patterns begin to emerge where randomness once seemed dominant. And still, the universe keeps secrets. You cannot directly observe the interior of a magnetar. You infer. You simulate. You wait. Patience becomes part of the scientific method. You start to notice how often the most important discoveries arrive indirectly. Gravitational waves reveal black hole mergers long after the collision. Neutrinos whisper from the cores of stars you cannot see. Gamma rays tell stories of magnetic fields you cannot touch. Reality is not obligated to be accessible. And yet, somehow, you are allowed glimpses. There is humility in this process. A quiet acceptance that understanding is always partial. Not because the universe is cruel, but because it is vast. SGR 1806-20 teaches you that extremes are not anomalies. They are natural consequences of scale. Given enough mass, gravity will curve spacetime. Given enough pressure, matter will forget its familiar rules. Given enough magnetic force, even solid crusts will fracture like thin ice. These are not exceptions. They are outcomes, and that realization reshapes how you see your own place in the cosmos. You are not standing outside the universe, observing it safely. You are embedded within the same rules, the same forces, the same long chain of cause and effect. The atoms in your body once endured pressures inside stars. The iron in your blood was forged under conditions not entirely unlike those inside neutron stars, though far gentler. The difference between you and a magnetar is not kind versus cruel. It is degree. This understanding softens fear. SGR 1806-20 is not a cosmic weapon aimed outward. It is a reminder that the universe operates without concern for comfort, yet still allows complexity, beauty, and thought to emerge. As research continues, scientists refine models, build better detectors, and wait for the next signal. Another flare. Another whisper across space. They know it will come. They do not know when, and neither do you. But perhaps the deeper lesson is not anticipation, but attentiveness. To live in a universe that does not explain itself fully is not a flaw. It is an invitation. An invitation to listen carefully, to revise gently, to remain open. And as you stand at this edge of knowledge, you feel something unexpected, not frustration, but awe. Because mystery does not mean ignorance. It means there is more to learn. And as your questions deepen rather than resolve, your attention drifts beyond knowledge itself, toward what it means to exist inside such a universe at all. You return gently to where you began, not to the moment of the flare or the distant magnetar, but to yourself, sitting quietly, breathing, aware. The universe has not changed during this time. SGR 1806-20 continues spinning in silence. Magnetic fields tighten and loosen far beyond your senses. But you have changed. You now carry an expanded sense of scale, not as numbers, but as feeling. 50,000 light-years is no longer abstract. It is a distance crossed by patience. The loudest sound the universe ever made was never about volume. It was about presence. An event so powerful that it reached you across the galaxy without asking permission, without announcing itself, without caring whether you were ready. And yet, it arrived softly, as data, as curiosity, as wonder. This is how the universe communicates most often. Not with spectacle, but with subtlety. You live inside layers of invisible influence. Gravity holds you to Earth. Magnetism shapes the planet beneath your feet. Radiation from distant stars passes through you constantly. Most of it goes unnoticed. The Magnetar flare was only remarkable because it briefly rose above the background, like a single wave cresting high enough to be seen from shore. But the ocean never stops moving. When you understand this, something shifts in how you interpret danger, meaning, and significance. The universe is not waiting to surprise you. It is always active, and still life persists. Earth has endured asteroid impacts, supernova radiation, solar storms, and cosmic bombardment. Yet it remains fertile, not because it is protected, but because it adapts. SGR 1806-20 reminds you that survival in the universe is not about avoiding extremes. It is about existing amid them, and perhaps consciousness itself arises from this balance. Complexity living on the edge of chaos without falling into it. You begin to sense that science and contemplation are not opposites. They are partners. Science measures what happens. Reflection explores what it means. When you listen to this story slowly, as a journey rather than a lesson, something opens. You realize that knowing the universe is not about mastering it. It is about belonging to it. The Magnetar does not know you exist, and yet, its flare altered your understanding. In this way, meaning flows one direction, from the universe into awareness. You are not here to be important to the cosmos. You are here to witness it. This is enough. SGR 1806-20 will flare again someday. Perhaps weaker, perhaps stronger, perhaps long after humans are gone. The universe does not pause for observers, but observation leaves traces. Every time you learn something true about reality, you align a little more closely with it. You become less separate, and in that alignment, fear softens into curiosity. The loudest sound becomes a quiet teacher. The violent flare becomes a lesson in impermanence. The silence that follows becomes space to reflect. You do not need the universe to be gentle to find peace within it. You only need understanding. As this journey ends, nothing resolves completely. There is no final answer, no closing statement that ties everything neatly together. That would be dishonest. The universe does not conclude. It continues, and so do you. You carry forward a new way of listening, not just for signals in the sky, but for the quiet realization that you are part of something vast, dynamic, and endlessly unfolding. And perhaps that is what remains after the silence. Because even when the universe says nothing at all, you are still listening. And that, too, is part of the story.